Yes friends, so now today we are going to understand the topic which is perfect square. Now, till now we were expanding by using identity a plus b whole square as a square plus 2ab plus b square. Now we will be reducing it in the form like if it is in the form a square plus 2ab plus b square, we can directly write it as a plus b whole square. So how to identify whether the given polynomial is a perfect square or not? So well, here are few steps which will help you to identify whether the given polynomial is a perfect square or not. So first point, it has three terms. The polynomial should have three terms for it to be a perfect square. Next, the first term should be a perfect square, like if it is a square. The last term, that is LT, it should also be a perfect square, like we have b square. And the middle term, which is written by MT, should be 2 into square root of first term multiplied by square root of last term. The middle term should be equal to plus minus, whether it should be plus or minus 2 into square root of first term multiplied by square root of last term. If the middle term is exactly equal to the 2 into square root of first term multiplied by square root of last term and other 2-3 conditions are also fulfilled, then the given polynomial is a perfect square. I know you will get a little bit confused, but let us solve this by using an example. Suppose I have a question like, we have a question to check whether given polynomial is a perfect square or not. So see, the question is x square plus 8x plus 16. So first term, which is x square, it is a perfect square. Last term, which is 16, it is also a perfect square. And the middle term, if you see, 2 into square root of x square into square root of 16, that is 2 into x into 4, which is 8x. So middle term is already 8x, right? So yes, if this all three conditions are satisfied, then the given polynomial is a perfect square. So yes, it is a perfect square. But even if one of the conditions would not have been satisfied, then the given polynomial would not have been a perfect square. Let us take one more example. Like, if we have y square plus 3y plus 9. Okay, so if we see, the first term is a perfect square, the last term is also a perfect square, but the middle term, it is not. The middle term is not equal to 2 into square root of y square into square root of 9. So 2 into y into 3, which is equal to 6y, which is not equal to 3y, which is given to us. So therefore, no, it is not a perfect square. It is not a perfect square. Let's take one more example. Like 4x square minus 2 plus 1 by 4x square. So we can see first term, it's a perfect square. First term, which is 4x square, it is a perfect square of 2x. Last term, which is 1 by 4x square, it is also a perfect square of 1 by 2x. And the middle term, 2 into square root of 4x square multiplied by square root of 1 by 4x square, which is 2 into 2x into 1 by 2x. So this 2 will get cut. So we will get 2, which is equal to the 2 which is given to us, and that is why yes, it is a perfect square. It is a perfect square. Okay, so that is how we'll be using this concept to finding for finding whether the given polynomial is a perfect square or not. Let's take one more question on this concept. Like question number 7, exercise 3a, question number 7, it has been given to us that 4x square minus 12x plus k is a perfect square. Okay, we need to find the numerical value of k. So how will we find it? So again, first term 4x square, it is a perfect square of 2x. Last term is k. Let's keep it that way. We don't know the value of k, but yes, middle term is should be equal to 2 into square root of first term into square root of last term. So middle term we have is 12x. Right now we can ignore the sign. It will be 2 into square root of 4x square into square root of k. So 12x is equal to 2 into 2x into root k. So this 12x upon 2 into 2x is equal to root k. X and x will get cut. 2 1s are 2, 2 6s are 2 1s are 2 3s are. So what I'll get is 3 is equal to root k. Squaring both sides will get 9 is equal to k. So the numerical value of k is 9. Okay, so if k is 9, then the given polynomial is a perfect square. Okay, let's move to one more question. Like we have question number 8. What term should be added to each of the following expression to make it a perfect square? Like first part we have is 4a square plus 28a. So we know that, see, if it is a perfect square term, then it will be a first term and last term. But if the given term is not a perfect square, okay, like here we have 28a, there is no square over here, then it will be a middle term. So to identify whether we are finding first term, middle term or the last term, the hint is the first term and last term will be perfect square. So one term is given which is a perfect square, but the other term is missing. That's why we need to find the last term. But if the given two terms both are perfect square, then we need to find the middle term. Let us see what I am talking about. Like see here, the first term given to us is 4a square, which is a perfect square of 2a, and the middle term given to us is should be equal to 2 into square root of first term into square root of last term. This is last term which we need to find. Like the same way we find k, we found k in the last question. In the same way here we need to find the last term. So here it will be 28a, it will be equal to 2 into square root of 4a square into square root of last term. So 28a is equal to 2 into 2a into square root of last term. So 28a upon 4a is equal to square root of last term. A cut, 4 1s are 4 7s are. 7 is equal to square root of last term, or 49 is equal to last term. If we square both the sides, then last term will come out to be 49. So 49 should be added to the given polynomial to make it a perfect square. One more question I would like to do. Like we have third question. 4a square plus 81. Now, in this if you see 4a square plus 81, both are perfect square. 4a square is also a perfect square and 81 is also a perfect square. So that means first term and last term are given to us. We need to find middle term. We need to find middle term. So first term, again we have 4a square, which is the perfect square of 2a. Last term we have 81, which is the perfect square of 9. Middle term is equal to 2 into square root of first term into square root of last term, which is 2 into 4a square into 81, which is 2 into 2a into 9, which comes out to be 36a. So 36a should be added to the given polynomial to make it a perfect square. 36a should be added to the given polynomial to make it a perfect square. Okay, one more question we like to do. Fifth question that we have. 49a square a4 plus 50a square b square plus 16b4. So now in this, if you see, we have all the three terms, right? But still it is not a perfect square. How? Let us just see. Like first term is 49a4, which is the perfect square of 7a square. Last term is 16b4, it is the perfect square of 4b square square. And the middle term should be equal to 2 into square root of first term into square root of last term. So it is 2 into square root of 49a4 multiplied by square root of 16b4. So we'll get 2 into 7a square into 4b square, which is equal to, this is equal to 56a square b square. So the middle term should be equal to 56a square b square. But what is given to us? Middle term given to us is 50a square b square. Therefore 56a square b square minus 50a square b square will get 6a square b square. Therefore 6a square b square should be added to make it a perfect square. To make it a perfect square. Okay? So this is how we're going to solve the question related to perfect squares. Okay? Thank you. So now I'll move to the next identity. It is a very easy identity which you have already learned in the previous classes. Like, if we have a plus b whole cube, this is a cubic identity, this is equal to a cube plus b cube plus 3ab in bracket a plus b. And next is a minus b whole cube, it is a cube minus b cube minus 3ab in bracket a minus b. So these are the two identities which we will be using now and solving a couple of questions related to them. Like, the first question that I have is question number 9. Let me take third question. We need to find the cube of x square plus y whole cube. Then it will be a cube, that is x square whole cube, plus b cube, that is y whole cube, plus 3 into x square into y, x square plus y. So this will be x raised to 6 plus y raised to 3 plus, now I'll open this bracket, this will become 3x4y plus 3x square y square. That's the final answer. So the identity is a plus b whole cube is a cube plus b cube, that is cube of first term plus cube of second term, plus 3ab, that is 3 into product of both the terms multiplied by sum of both the terms. And in the same way, if we have negative a minus b whole cube, it is a cube minus b cube minus 3ab in bracket a minus b. All terms inside will be negative. When we open the bracket, the signs here will get changed. Let's see how. Let me take one example of the negative term. We have 2x minus 1 by 3x whole cube. So this will be equal to a cube minus b cube minus 3 into ab, 3 into 2x into 1 by 3x in bracket 2x minus 1 by 3x. So this x and this x will get cut. this 3 will get cut. We'll have 8x cube minus 1 by 27x cube minus 2 in bracket 2x minus 1 by 3x. I'll open this bracket again. So this is 8x cube minus 1 by 27x cube minus 4x plus 2 by 3x. So you look over here, minus minus get plus and the sign got changed, 2 by 3x. So that's my final answer. So with this I complete exercise 3A. So I'll suggest you to complete all the questions of exercise 3A once again, including the questions which have been done by me on the board and the one which you are still remaining. All the questions you have to complete and send your pic to me on WhatsApp. Thank you.